Hi, it's Mrs. Salee. I'm going to go through this and give you hopefully some feedback on how to do the study guide. So please make sure you have something to write with, and we're going to go through this. You know you can always pause this video so that you can actually write down stuff that you need to. All right, here we go. On this first set, you'll see that it had several directions. You need to write what it is, what causes it, and draw a picture using arrows to show the direction of the force. It looks like the first one I'm going to do is friction. Now, so what is it? It's a force that opposes motion. So that's what I'm going to write first. Force that opposes motion. Now, I apologize. I'm doing this on the iPad, so it may not be perfect, but it's going to be close. And I'm writing this, if I was doing it on my paper, on one of those little boxes. It's caused, that's the next piece. Notice that you don't have to write complete sentences. It's caused by the hills and valleys of the surfaces catching on each other. Remember, so I wrote the force that opposes motion. Second thing is I said it was caused by the hills and valleys of both the surfaces catching on each other. I didn't write on each other. And then if you want to draw a picture, some people drew you can draw like there's my box, here's my surface, and I'm moving the box this way. Now you remember friction's probably a smaller force, and it's opposing motion. So that's my little arrow that's drawing the direction of friction. I'm going to write friction so I don't forget it. But friction is opposing my motion. So it's going the opposite direction. All right, so here's the next one. It's gravity. Gravity is a force of attraction between all matter. So that's what I'm going to write first. It's a force of attraction between all matter. That means anything that has mass has gravity. So when I want to talk about what causes it, so that was what it is. What causes it? It's caused by anything that has mass and also by the distance between the objects. Gravity does not push against anything, it pulls. It always is pulling things together. So if I have two objects, here's my sun and the earth, believe it or not, they both are exerting a gravity, but what they do is they pull. Okay? So the earth is pulling it toward it, and this thing is pulling it toward it. And that would be my diagram. Centripetal force is a force that causes an object to go on a circular path or a curved path. So I'm going to write, you notice how we always start with force. Force that causes object to go in a circular What causes it? It's because a force is pointing or directed. I'm going to use the word directed toward the center. If that was not true, things would be flying off in a straight line, because we know all things want to go in a straight line unless we push or pull them to cause them to go otherwise. So here's my motion. That's my circular path that all centripetal forces make things go in a circle. And then my centripetal force is something is pulling it toward the center. So I'm going to put CF for centripetal force. Notice it's pointing toward the center. Okay, so I have the word buoyancy as one of your words. I should have used buoyant force, because that is what I was really wanting. And a buoyant force is the upward force of a fluid. and it's caused by the differences in pressure. So I'm going to write that. Maybe I'll write that. Let's do this here. Change my color, it looks like. Differences in pressure. So if I've got this thing and we got a liquid in here, down here it has more pressure. Up here there's less. And because of that, this upward force, the buoyant force, is greater down here because there's more liquid pushing down on it. So I'm going to say this one a little bit differently. For magnetism, it's caused by the motion of electrons. So I'm going to start with the cause this time. Caused by motion of electrons. And what it does and what it is that we have like either an attractive or repulsive forces between objects. So I'm going to put plus or negative forces between objects if they are magnetic. If we had a picture, a lot of times if you've seen a magnet, there's a north pole on one side and there's a south pole on the other. So I could have two different things. If I have that is one thing that happens when the two sides are the same, and if that happens, they do not want to be next to each other, and so they are going to actually push each other away. They do not like it. And the other option that sometimes happens is you may have a north pole and a south pole that are the same, but this time they attract each other, and so they try to get closer. So that looks like that. And so those would be my force arrows right here for my magnetism. Remember, opposites attract on magnets. All right, so now contact force. These are forces where things that have to be touching. Things, objects, things are touching. That means they're in contact. And pushing or pulling. That's what's causing it. They're pushing or pulling. You could have a box again, and here's a person. I'm not the best drawer. Look how long he is. Oh, look, that's pretty good actually. And he is pushing it. That's a contact force. Done. This will be a little easier. Write an example for each force listed. As long as you have two surfaces touching and rubbing against each other and it's opposing motion, you've got friction. It could also be something like using sandpaper, because you use sandpaper to create friction. So I'm going to use using sandpaper for my example. So when we look at gravity, I could do anything where the Earth's pull is pulling us down. So it could be a volleyball hitting the ground. Or you could be very fancy and talk about the tides, and the tides are also caused by the moon's gravity. If you didn't know that, now you know, even though that's terribly spelled. Sorry. Centripetal force. It's something that has something going in a circle. Tetherball is a game that has a centripetal force going. The Earth or the moon going around the Earth, moon orbit, it has to do with the centripetal force. Well, anything that's in a circular path. Buoyant force. Depends. If the buoyant force is greater than an object, you could have a boat floating. So things float because of a buoyant force. Actually, I've got that L in there. I almost missed it. Or things sink because the buoyant force wasn't big enough. So a submarine uses buoyancy to actually rise and to sink. It's pretty cool. I misspelled submarine. It's okay. You can understand. So magnetism's done. It's using a compass because a compass points to the Earth's magnetic north pole. But anything that has magnets. And finally, contact force. It's anytime you push or pull. You could have kicking a soccer ball. Oh, that's just lovely. The key here are the two objects touching. Remember, magnetism is an example of non-contact force, and the other non-contact force is gravity. Hey, I just said this one. That's pretty nice. Contact force. Two things are touching, or more. Could be more than more, but they have to touch. Surfaces are touching. Non-contact. They could be touching. They do not have to touch. So for example, I'm sitting here in this chair right now, but gravity is still affecting me. And but it doesn't have to. And magnets, they can still be magnetic whether they're touching or not touching, but they do not have to touch. Now there are other types of non-contact forces, but in 8th grade, I think these are good. So let's get the non-contact force out of the way first, and I'm going to put non-contact force, so just abbreviate it, and it's going to be gravity. If I was to ask to draw a picture or draw an arrow for gravity, that's the way it's going for the force arrow. Now we have some contact forces. So my first one, I am going to be right up here. He is pushing down like that on his foot, so the contact force would be foot pushing down. And then I'm going to do one right here that his hand, you see that right there? It's a small one, but his hand is pushing in the water. All right, we have a buoyant force because this is a boat. So just to give you another one, we have this buoyant force of the water holding the boat up. Can we find another one? Air resistance. That's one that's almost always there. And we can talk about friction. Air resistance going all different ways. If I was going to draw little arrows, because air is a fluid again, so it goes everywhere. All right, so that's, and all of those are contact forces, these bottom ones right here. Balanced. No change in motion. So it's either going at a constant velocity or it's stopped. Unbalanced, on the other hand, has a change in velocity. And just to review, that means it can speed up, slow down, or change direction. In simplest terms, work is force times a distance that it moves. We talked about in class that the force is always measured in newtons, the distance is always measured in meters, and the work, when we measure it, is always going to be measured in joules. All right, we have our first math problem. It says a runner impacts the ground with a force on her heel of 2,000 newtons. If she runs a distance of 3,000 meters, how much work does a runner do? All right, so we know we have to take the force, which is 2,000 newtons, multiply it by 3,000 meters. So I'm going to sit there and go, okay, so there's 1 0, second 0, third 0. I don't know how you do this, but this is how I'm doing it. Another 0, there's another 0, there's another 0. And then 3 times 2 is 6. That's a 6. So then, oh my goodness, that's a lot. So it looks like it's 6 million joules. That's how much work she did. That's a whole heck of a lot. All right, this one. A strong golfer hits a golf ball with a force of 18,000 newtons. If the club contacts the ball for a distance of 1/100th of a meter, how much work was done? Okay, so we have our force. And then we're going to multiply that by our distance. So 1 times 0 is 0. 1 times 0 is 0. 1 times 0 is 0. 1 times 8 is 8. 1 times 1 is 1. Okay, and then I notice that I have 2 decimal places, so I have to put it there. So my final answer is going to be 180 joules. Okay. All right, so now we have a dozen bagels while it weighs 11 newtons. If the bag is lifted a distance of 1.5 meters, how much work was done? 5 times 1 is 5. 5 times 1 is 5. Bring down my 0. 1 times 1, 1 times 1. So I have a 5, a 6, and a 1, but I have 1 decimal point. So it's 16.5 joules. None of these did any division where you're going to have to find distance or force, like, use the formula and work it around a bit. But you will have one on the test that's different, where you'll have to do a dividing. Just a warning. So the last thing is the performance event scenario. It's from your test that you did, and it says write up a complete conclusion, and I did pass out a sample page that you could take home, so we're going to go through these step by step. I started with my claim, and I made my claim first by looking over here at the temperature of the water, and I noticed that it got bigger. It went from 25 to 50 to 100. And then I noticed over here that as the temperature was going up, these numbers were going down. They went from 60 to 35 to 20. So that's how I made this claim. As the temperature of water increases, the time it takes to dissolve the Alka-Seltzer tablet decreases. So now I have to back it up with evidence. So all I did is I looked and I took these and I made them in sentence forms. So it says it took an average of 60 seconds to dissolve the Alka-Seltzer in 25-degree water. And when the water was 50 degrees, it took 35 seconds. And when the water was 100 degrees, it took on average of 20 seconds. So those are my sentence forms of what I needed to write. You know what I did next? I Googled it. So why does this happen? Why does Alka-Seltzer, why does it take its less time in hotter water? And here's what I found out. In hot water, the molecules move around more quickly. This means that when they hit the Alka-Seltzer tablet, they do so more quickly and with more force. That is why as you increase the temperature of the water, the Alka-Seltzer takes less time to dissolve, because they're being bombarded faster and faster. Then I had to put it all together. So here is my claim. Here's my evidence. Here is my reasoning. And again, I got this reasoning off of Google, but you just need to ask yourself, because you can't do that on the test, why? Why do I have the results that I did? Hey, guess what? You're done. I need to say a couple things. Number one, good luck on your test tomorrow. Feel free to review this tonight. You've got access to it if you need to, either on Edmodo. It's also in your Google Drive. So good luck on your test, and let your teacher know, your substitute. Show them your paper so that they can see that you've finished your assignment. I just need to start this. That's what I was making, and then I went to go and